When the diver enters the water in the scuba training pool, the water level rises. We can see this by looking at the water level zoom window at the right. To displace some amount of water, the diver has to push on the water. In return, the water pushes on her, creating a buoyant force. The amount of buoyant force is equal to the weight of the displaced water. It is a fixed amount once the diver becomes fully immersed, no matter how deep. By setting the force vector slider to buoyancy, we can watch the buoyant force stay constant, no matter the depth of the diver. We adjust the depth using the depth slider. This depth is to the center of mass of the diver, not her head or feet. So the buoyant force acting on the diver doesn't depend on depth. And this might seem strange. After all, you might know that the water pressure does increase with depth. As the diver goes deeper, we can see in the graph at right that the pressure does increase. Shouldn't a diver then feel more force as she descends to higher and higher pressure? Well, think of it this way. The water is pushing on the diver from all sides, top, bottom, and all around the sides. We can see this by turning on the pressure force vectors using the force vector slider. Note that all the different pushes from the sides of the diver will all cancel. The net force from the water depends on the difference in water pressure at the top of the diver and at the bottom. This difference doesn't change with depth, and so the net force from the water pressure, known as the buoyant force, doesn't change with depth. You might notice that the chart at right and the gauge at left don't read out the same thing. Isn't that weird? That's because the gauge at left reads what is known as gauge pressure, the amount of pressure above 1 atmosphere. A gauge like this would read out 0 atmosphere if it was just sitting at normal pressure at sea level. A gauge measures pressures above atmospheric and doesn't include the 1 atmosphere pressure we find everywhere at the Earth's surface. One very common misconception students harbor is about the density of water with depth. The density of water doesn't change significantly with depth into the water. The molecules in water are as closely packed together in liquid form as they can be. You don't get much more tightly packed even with a mountain of water sitting on top of you. So the density at the bottom of the ocean is about the same as the water in a cup sitting at your table. But the pressure is much more. After all, the water pressure at the bottom of the ocean needs to be able to support the weight of all the water above it. And that's a lot of weight. Water is heavy. Be sure when learning this material that you think carefully about the difference between density and pressure. Hope you've enjoyed this tutorial.